Today we are going to be discussing substitution, only day 2, so you have a background idea of what we're looking for. Today's problems are just going to be slightly more challenging. So again, what we're going to do is we're going to go ahead and say, here's what my y equals. Okay, but now where I plug it into, my second equation is just in a different area. So this time, instead of plugging it in on the other side of the equal sign, I'm going to plug it in right to where that y is. So I'm just going to rewrite that second equation just like I did yesterday. So I have 2x plus, but instead of y, now I have the quantity x plus 4. Notice I put that in parentheses, and then that equals 1. And now I have an equation with only x's, and I can go ahead and simplify. So I've got 2x plus 4 equals 1. So I put my x's together. That's 3x plus 4 equals 1. To solve for x, I would subtract 4, leaving me 3x to equal a negative 3. Dividing each side by 3, so I get x to equal a negative 1. Again, just like yesterday in our first day of substitution, we also need to know our y-coordinate. So my equation says y equals x, which is negative 1, plus 4. So my y is 3. So my ordered pair is negative 1, 3. Okay, so just like yesterday, only kind of just being a little bit more careful about where we are substituting our values. Example B. This time, my first equation doesn't have an x equals or a y equals. That comes in my second equation, which is what x equals. Okay, typically we've been dealing with a y equals, but it doesn't matter as long as it's equal to one variable. So again, I can box what x is equal to. And now this time I'm going to plug it into my first equation, and you're plugging it in for x because that's what my quantity equals. So when I rewrite that first equation, I've got 1/4 x, but instead of x, I've got the quantity 8y plus 48. And then I continue on with that first equation, plus 2y equals 28. Okay, so again, I have what x equals, I box it, and I plug it into where x is. So to simplify this, I'm going to distribute, leave me with 2y plus 12 plus 2y equals 28. I'll put together my like terms, so that's going to give me 4y plus 12 equals 28. I'll subtract 12 from each side, leaving me with 4y to equal 16. Divide by 4, so y will equal 4. Again, I need to know both variables, so I'll use that second equation, which says x equals 8y, and I know y is 4 plus 48. So my final answer there is 80. So my ordered pair is 80, 4. Okay, let's try another one. Example C. Well, now example C is getting a little trickier because I don't have an x equals or a y equals. So what I want to do is I want to solve one equation so I have only an x equals or a y equals. So if you look at that, the first example, the first equation is kind of tricky because I also have 3's on them, or negative 3, so I'd have to do a lot of work there. My second equation, I could see that I could solve for x rather simply by just adding 5y to each side. So that's what I'm going to do. So this equation can be rewritten as x equals 3 plus 5y. So now what I'm going to do, I have an x equals, so I'm going to go ahead and I'm going to box that, and that goes into my first equation right where x was. So if I rewrite that first one, I've got negative 3, and then instead of x, I have the quantity 3 plus 5y plus 3y equals 15. And now I can simplify by distributing. Negative 9 minus 15y plus 3y equals 15. Putting together my like terms, that's going to give me a negative 12y. Watch your negatives there. Okay, and this time I'm going to add 9 because that's negative. So I've got negative 12y to equal 24. Divide by negative 12, so y will equal negative 2. Okay, so now I need to find my x value, so I'll plug that in. X equals 3 plus 5 times y, which is negative 2. So that's going to give me 3 minus 10, which is negative 7. So my ordered pair is going to be negative 7, negative 2. Okay, so that's kind of similar, like example D, as we move on here. I only have a y minus 6 or an x plus 3 plus 2y. So what I'm going to do is see which equation would be easier to get a variable by itself. And that would be this first equation. I could just add 6 to each side. So that first equation is the same thing as y equals negative x over 6 plus 6. just not get confused there. So that's what my y equals. So I can go ahead and square that. That's going to go into my second equation for y. Just remember and watch your work carefully. Whatever equation you rewrite, you're always plugging into the other one. Okay, I've seen students write it into the wrong, or substitute it back into the same equation, so just watch your work. Okay, so when we plug it in the second one, we've got x plus 3 plus 2, and then instead of y, I've got the quantity negative x over 6 plus 6, and that equals 12. So I've got x over 3 plus, let's see, that's 2 times 1/6, so that's negative 1/3 x plus 12 equals 12. And x over 3 is the same thing as 1/3 x, so 1/3 x minus 1/3 x is 0. So I'm left with 12 equals 12. So what happened here is all of my variables canceled out. So this is going to be one of those interesting cases where we just don't have one. We either have infinite solutions or no solutions. Well, if I look at this, 12 equals 12 is a true statement. So my final answer is going to be infinite solutions. Because what's really happening is this is 2 ways to write the exact same line. So it's got infinite number of solutions. Example E looks again kind of crazy, a little bit like yesterday. This is going to be a double substitution. So I can go ahead and box where my y is and plug that into y. And I can also box where my z is, and then I'm going to plug that into my z. So I'm going to rewrite just that first equation as negative 3x minus 1/2, but instead of y, you're substituting in 8 minus 6x. Then I've got plus 4z, but instead of z, I've got 1/8 x plus 2. And then that equals negative 8. Okay, so a double substitution, you're substituting the bottom 2 into that first one, and I only have x's left. So now I can go ahead and simplify by distributing. So I've got negative 3x minus 4 plus 3x. I'll also distribute the second set of parentheses, which will give me 1/2 x plus 8 equal negative 8. So I'll continue simplifying. My negative 3x and my positive 3x will cancel, leaving me with only 1/2 x. Then I've got my numbers, negative 4 plus 8 turns out to be a plus 4. That equals negative 8. Now I can solve. So I'll subtract negative 4. So I've got 1/2 x equals negative 8 minus 4 is a negative 12. And then divide by a half is negative 24. And then if you remember from yesterday, this is going to be a double substitution. I also need to know that y equals 8 minus 6 times negative 24, which is going to give me a positive 152. And then I also need to know that z is 1/8 of negative 24 plus 2, so that's going to give me a negative 1. So again, when we write our final ordered pair, it's in alphabetical order, x, y, z. So I've got negative 24, 152, and negative 1. A different kind of question might ask you to give you the solution, and then you write the system that would have that as a solution. So if I know that I've got negative 7, 10, I know that negative 7 is my x coordinate and 10 is my y coordinate. So I could just do something as simple as maybe x plus y equals 3. Because if you plug in negative 7 plus 10, you get positive 3. Okay, I could also do something like, I don't know, y minus x would give me 17, because that would be 10 minus negative 7 would equal 17. So any set of equations that you want to come up with where this, when you plug it in, gives you an answer is all good. And back to our favorite theory problems. Example G says a theater sells children's tickets for $4 and adult tickets for $7. One night, 575 tickets were worth $3,575. How many adult tickets were sold and how many children's tickets were sold? Okay, well, if I know a children's ticket was 4, an adult was 7, those are kind of my two variables. So x would be my adult and y would be my children. So then I could go, oh, maybe I should do that the other way. Let's make x our children, because they listed that first. That'll just keep things a little bit straight. And then y is our adult. So my system would be $4 for the children's ticket plus $7 for my adult ticket is $3,575. So that equation, I'm just going to write a little note over here, deals with the money. I need a second equation because this is a system, and the second one will deal with a number of tickets. Well, they said that that was 575 total tickets, and that was just a combination between the two types that we sold. So there won't be any coefficients there. It'll just be x plus y because those are the numbers we sold. Okay, so now we need to solve this one, but I don't have an x equals or a y equals. So what I could do is rewrite this second equation for y by subtracting x. So this one is the same as y equals 575 minus x. So I'm going to put a box around that and plug it into my first equation where y is. So that's going to give me 4x plus 7. And then instead of y, I'm going to have the quantity 575 minus x. And that equals 3575. So again, I'll just distribute here. 4x plus 2300 minus 7x equals 3575. I'll go ahead and put my x's together. That's a negative 3x plus 2300 equals 3575. So I'll subtract 2300 from each side. Hopefully we're getting really good at this because we've done a lot of examples now. Equals 1275 divided by 3, and that should give me 425. And then if I plug that into my first equation, which said x plus y equals 575, and I plug in 425 for x, that's going to tell me that y equals 150. So I would have xy 425, comma 150. Okay, very good. Let's try another story problem. A mother and daughter had a rummage sale. Altogether, the profits were $235. However, the mother made 3 times as much as the daughter. How much money did each earn? Set up a system of equations. Okay. Define the variables. Okay, so we were told right here that M is mom and D is daughter. So then I know that together, the mother and daughter sold $235. Okay, so this one deals with the money. The second one is going to deal with the fact that the mom made 3 times as much as the daughter. So that means 3 times what the daughter made is what the mom earned. Okay, so 3 times what the daughter made is the mom. So this one's nicer. Okay, it's already set up in substitution. So, oops, I squared the wrong one here. Sorry, equals M. So M equals 3D. So then I'm going to plug that into M up there. So I've got 3D, and then plus D equals 235. So that's 4D equals 235. So D will equal 5875. If I plug that back in, I've got 3 times 5875 will equal what the mom made. So the mom made 176.25. Okay, so an ordered pair would be the daughter, 58.75, comma, mother, 176.25. The really nice thing about this is you can just plug those values back into either equation to make sure that you did them right. So that's the trickier versions of substitution. Your homework is going to be on lesson 11, 3B. Go ahead, work on it, and let me know when you have questions tomorrow.